Okay, yesterday we learned how to put in the matrix to solve for unknown variables. So we are going to do that. The good news is, y'all look at this equation, or these two equations. This is just two variable, two equation system. So when we first learned how to do this, we did elimination, substitution, we had to do all that work. But the great news is we can use matrices to solve these two. So whenever you have your test next week, you don't have to know how to do substitution and elimination. You can put it into the calculator if you want. So it says create three matrices. We're just going to go straight to our matrix. So we put this on as a matrix, but without the x and y, just with the coefficients. And we're just going to talk about how we put it in the calculator. We know that it's going to be an equation that we solve for, and we do the inverse. So let's go ahead and write inverse on there. So inverse of matrix A times our constants that are on the other side of the equal sign. And we are going to put this into the calculator. So let's talk about how we'll do that. So hit clear whatever's there. We're going to do alpha zoom. And this is a 2 by 2 matrix. So we need to do that. When we had 3 variable 3 equation, it was a 3 by 3. But now we have 2 variable 2 equation, so it's a 2 by 2. So change it to a 2 by 2. Put in those values. And then hit the button for inverse. Everybody should be doing this with me, same time. Then we need to put in the other matrix. What's that second matrix going to be? How many rows does it have? 2. How many columns does it have? So the second one's a 2 by 1. So see if you got the same thing as me. So it comes out as negative 208.75. So we just need to find out what the x value, what the y value is. So you just look at what order did we write them in. The equations were written in x, y. So this first number is x, the second number is y. So when we write our solution, we're going to do negative 208, comma 75. Okay, go ahead and do example 2. guess I already did it, didn't I? Negative 2, 4. So the x value is negative 2, the y value is 4. So we would write it as negative 2, 4. Okay, the last one. So this is a 3-variable, 3 equation. So let's go ahead and write this one. The first equation's in the right form. It's in x, y, z. The second equation's in the right form. But the last equation's not in the right form. It needs to be x, y, z. So x, is there, it would be 1x, wouldn't it? Is there a y? No, so 0y. And 2z is on the wrong side. So how do I rewrite it so it's on the right side? So minus 2z equals a negative 8. So this will be 1, 0, negative 2. Do your inverse, and then write your constants. So now we're going to start with the 3 by 3. Remember, we have 3 variables. 3 by 3. And then the second matrix is a 3-row by 1 column. Okay, so we get negative 0.5, 4.75, and 3.75. So we have x, y, z. It does say to convert decimals to fractions, we can hit math, enter. And it'll actually change them to fractions, which is a good thing sometimes. If we're talking about money, that wouldn't be a good thing. So this is x, y, and z. All right, so we usually see these type of problems as word problems. So go to the next page. We're going to read over the prompt. The Arcadium Arcade in Lynchburg, Tennessee uses 3 different color tokens for their game machines. For $20, you can purchase any of the following mixtures of tokens. 14 gold, 20 silver, 24 bronze. Or 20 gold, 15 silver, 19 bronze. Or 30 gold, 5 silver, 13 bronze. What is the monetary value of each token? So underline the question. We want to answer. How many tokens do we have? Well, how many types of tokens do we have? 3. What are they? Yeah, so our variables are going to be G for gold, S for silver, B for bronze. So if you're not sure what to call your variables, look back at what the question's asking. It says, what is the monetary value of each token? So these all are talking about the monetary value. So how much is each token worth? How much is gold worth? How much is silver? How much is bronze? The little tokens that they are selling. So we are going to look at all the parts to figure out what the equations are. So there's 3 equations. So it says for $20, you can have any of the following mixtures of tokens. So the first one, 14 gold, 20 silver, 24 bronze. We're going to write this as an equation. So 24 gold, so 24G, no, not 24, sorry, 14 gold, plus 20 silver, plus 24 bronze. How much is that going to cost? 20 bucks. Then the next one says, or for that same 20 bucks, 20 gold, 15 silver, 19 bronze. We're going to write that as an equation. And then what do you think the last equation will be? There we go. And so we have 3 equations all in standard form. So we are going to use matrices or matrix to solve this. So write your matrix down before you go and put it in your calculator. Yes, I believe so. Did y'all get decimal answers? Oh. Okay, so since it's a word problem, we do have to write our answer in words. So I got 0.5, 0.35, and 0.25. But remember, we're talking about value. So we need to attach dollars to this. So like 50 cents, 35 cents, 25 cents. Or you can write it like this. Or 50 cents. So you want to make sure that you write it in the correct way. So 50 cents, maybe it should be dimes are worth. Not dimes, gold. Gold is 50 cents. Gold tokens are. Maybe I should put it like that. I'm trying to write it the correct way. Gold tokens are 50 cents. silver tokens are 35 cents. And bronze tokens are 25 cents. So word problems need word sentence answers. Okay, let's go to the next one. A theater sells tickets, $6 for adults, $3.50 for students, and $2.50 for children under 12 years old. A total of 278 tickets were sold for one showing, with total revenue of $1,300. If the number of adult tickets sold was 10 less than twice the number of student tickets, how many of each type of ticket were sold for the showing? Okay, so how many of each type? So that is our question. So what are the variables then? A for adult tickets. S for student. C for child. Okay, so let's look at what each sentence tells us and how we can come up with three equations. Theater sells tickets $6 for adults, $3.50 for students, $2.50 for children. There's a total of 278 tickets. Revenue of $1,300. So we have two totals. We have a total of how much money. We have a total of how much tickets. So we can actually come up with two equations with this. So if I'm talking about all the money, then I need to put all the money in one equation. So it'd be $6 times the adult, plus $3.50 times the student, plus $2.50 times the child, gives us a total amount of money, $1,300. So I'm going to call this equation my money equation. Money, money, money. It has all the money. Because we have a total amount of money and we have amount for each one. Okay, we need another equation that tells us 278 tickets. What adds up to equal the whole 278 tickets? Not money. We're not talking about money anymore. What adds up? Don't overthink it. Huh? The number of tickets. How many types of tickets do we have? So our three types of tickets will add up to give us 278. So this is total tickets. Not as exciting as the money, but total. And then our last equation comes from that sentence about the adult ticket sold was 10 less than twice the number of student. Okay, so whenever you have to translate words into a math equation, we're going to use the variables and numbers and operations right above it. So adult ticket, so A goes above adult tickets sold. The word was translates to equal. So adults equals. It says 10 less than twice student. So how can I say 10 less than twice student? Negative 10. What needs to go in front of negative 10? 2 what? Times. 2 what? 2s, yeah. 2s is twice the number of students minus 10. So that is our third equation. Okay, so we have the equations, so now we need to make a matrix out of it. As long as it's in A, S, C order. So you can decide what order. So this would be our matrix. So this one is in the A, S, C order. So we would put the first number would be 6, then 350, then 250. The second equation is also in ASC, so 1, 1, 1. But the last row is not. So we've got to rearrange this so it's in ASC order. So I'm just going to write it over here. A equals 2S minus 10. So A is in the right order. So A, so that'd be 1A. We got to get 2S onto the other side. Other side of the equal sign. So it's going to be minus 2S. And then there is no C, so what do I put in the place of C? So 0C equals negative 10 stayed where it was. So we have the equation, put it in the matrix, 1, negative 2, 0. We do the inverse of that first function, and then we put our constants on the other side, or inside the second matrix. And that'll make it where we can solve for children, students, and adults. So let's go to our calculator. We've got to put this in. So alpha zoom. This is a 3 by 3 to start us off. Put it in your calculator. Everybody do it. Alpha zoom. Put your coefficients in. Make sure you put a negative and not a minus 2. Then hit the inverse button. Alpha zoom. Now we need a 3 by 1 to put our 1300, 278, and negative 10. Push enter. We get the same thing. 150, 80, and 48. Okay, so we've got to identify which one's which. So what order did we do to begin with? A, S, C. So we do that same order. It's a word problem. So we need to write our answer in words. So read the question again, not the whole thing, just where the question mark is. So how many of each type of ticket were sold for the showing? 150 adult, 80 student, 48 child. That's all we got to write. So 150 adult tickets, comma, 80 student tickets, comma, and 48 child tickets were sold. were sold.